When several atoms are placed close together enough, its orbital energies mix to form molecular orbital energies, which is also called quantum energy level. As number of atoms approaches to infinity, the energy levels of each atom will be very close enough to be considered as bands of energy. So according to band theory, semiconductors can be either be an insulator or conductors, depending on the temperature. At absolute zero, semiconductors act as an insulator, and if temperature is above absolute zero, it becomes a conductor, and yet still staying below the melting point of the solid, the metal would act as a semiconductor. Semiconductors consist of fully occupied valence band and an empty conduction band. With a small band gap in between these two bands, it takes a certain amount of energy to excite the electrons from the valence to conduction band. Thus, it follows that the higher the temperature, the more conductive the solid will be. So, as stated previously, continuous bands of energy are formed due to combinations of molecular orbitals close in energy. So the difference between these band energies, which are valence band and conduction band, is known as the band gap. The band theory looks at the jump of the electrons across the band gap. In particular, the jump of electrons from the valence band to the conduction band across the Fermi energy level. This jump indicates the optical and magnetic properties of the solid. So what is a valence band? A valence band is the band of electron orbitals that electrons can jump out of, which directly contributes to the conductivity of the solid. The conduction band is where the positive or negative charge carriers exist. Also, the Fermi level is basically the 50% of the electron density state. Lastly, what I want to say, what I want to explain is the difference between an extrinsic semiconductors and intrinsic semiconductors. The pure form of the semiconductors are known as intrinsic semiconductors, and the semiconductor in which intentionally impurities are added are known as extrinsic semiconductors. And the conductivity of intrinsic semiconductors becomes zero at room temperature, while the extrinsic semiconductor is very little conductive at room temperature. Thank you.